0. So you're looking at EA equals Q enclosed over E naught, right? So shape I drew, I choose to draw as a cylinder. I gave you as a big hint. And the only other thing I know is hat boy, their charge per unit area, is 7.5 times 10 to the negative 6 coulombs per meter squared, because it's an area thing.
Is that the second time you tripped on that?
Yeah, there's a nice little yellow cord out here. Somebody was helping me with my cords. So I'm going to get that back in there. Everything fell out of the bottom, so I'm guessing somebody help me out with that, but whatever. Well, let's figure this out. Let's figure this out. So E, what's the area? Well, I've got a cap here and a cap here, and I'm hoping nothing goes out those sides, right? So my area is going to be 2 pi r squareds, right? Because each one of those is going to be a circle, right? Now this r is a little bit awkward because we know I just picked the r. Well, that's not good. You're not allowed to pick the r, Mr. Resney. I know. I know. Not allowed to do that. So I better get an r squared on the other side, otherwise I'm in deep trouble. Charged enclosed. How am I going to get my charged enclosed?
Charge multiplied by the area that it encloses.
Right. So what's the shape of the area that I'm enclosing?
Circle.
A circle, right? Because I cut a circle out of it, right? So as I slice through it, I slice through this piece, I'm basically making a circle in the middle. So the area would be, so it'd be hat boy times the area. And then moving down one more line, I get E 2 pi r squareds equals hat boy times, what's the area of that? The area that's going to be pi r squareds. And so the size of the circle I picked, which shouldn't matter, doesn't matter. Charge per unit area over 2 E naughts. Which tells you something interesting. It doesn't matter how far I am from that sheet, as long as I don't get near the edges. Again, if your sheet looks like this, and the shape you're drawing looks like this Gauss don't work, right? But if your sheet looks like this, and your shape looks like this, Gauss works fine. There's nothing slipping out the two sides. All right?
So 7.5 times 10 to the negative 6 divided by
2
times 18
divided by 8.85 times 10 to the negative 12.
4.2 times 10 to the 6 times 10 to the 5. Yeah. Or no, this is new script. So,
Electric field. So what'd you get?
4.2 times 10 to the 5.
4.24 times 10 to the 5th. Yep. It's Coulomb. Interesting, Mr. Reith. Sometimes you go 5 digits, sometimes you go 2.
Yep. I do 3 digits most of the time.
In calculus class, that's disturbing. In this class, probably fine. So on 17, A, 0, B, 0, C. Have to do a little work.
So with 17, you're using the principle from 16 for part C, because it's just outside the.
Yeah.
Okay. Yeah. So they don't.
Yeah. So you could certainly use that information you wanted to. I'm going to do it from original principles simply because I'm lazy like that.
I mean, I started.
What am I going to do? Forgot I was dealing with a sphere. Sphere, correct? Yep. 4 pi r squareds. Good. All right. With that in mind, on C I got 2.7 million Newton per coulomb.
Oh dear.
Uh-oh. He got the different answer too, so let's worry about my answer.
I forgot to square mine. I got like 40463121.
Okay. Let's see here. We're gonna go astray. Are my numbers right? I did 12 10 to the negative 6.
I might be wrong.
12 10 to the negative 6. 8.8 Q naught over E naught. 8.85 times 10 to the negative 12. Let's see if I typed that in correctly. I did. Divided by 4, divided by pi, divided by point squared, squared. I'm liking my answer now. So my cat did not let me down. That's probably a good answer. All right, here we go. That's a nanocoulomb times 10 to the negative 9. So we got 25 times 10 to the negative 9th nanocoulombs. Okay, so what am I going to do in this case? I've got a solid copper. Copper is important in this sentence. Sphere.
Does it have a uniform distribution?
If it's copper, it's what?
Metal?
Conductor, right? It's metal. Any kind of metal, you're going to assume this that's a conductor. If the conductor, where does all the charge arrange itself?
On the outside.
On the outside. So all the charge is effectively out here. If that's the case, what is the electric field 24 centimeters from the center? It's going to be 0. So A is going to be electric field equals 0 newtons per coulomb. B, now I have to do some work, right?
And are you going to do what you can do?
Right, because, exactly, same thing, no changes there at all. And in fact, question D is, how would you answer to change the sphere were hollow? Answer, not at all. The charge would still be arranged on the outside, still be arranged in a thin layer, all my answers would be the same. Right? So I have an integral of E dot dA equals Q enclosed over E naught. EA, E times 4 pi. The shape I'm going to choose to draw is going to be a sphere of radius 0.26. So that would give me 4 pi 0.26 squared. It's equal to charge enclosed. They put a total of 25 times 10 to the negative 9th coulombs on this thing over 8.85 times 10 to the negative 12th, because that's the magic number.
Nano is 10 to the negative 9, right?
9 times 10 to the 9th, yep.
If we go on the test, maybe it's like something we don't know like that, like nanocoulombs.
It's on the front of it's in your front sheet.
What did you guys get for part B?
Still working on it.
I got 43,000.
Divided by 0.84949. Bam. I got 33. I got 3,300. 3,320 at 30. All right. If you guys want to go watch the rest of the basketball game, you are